Okay, last one. This is from Lesson Master 610A from your homework packet that you're hopefully finishing up over this weekend. And I just want to give a real quick overview of 12 and 13. I'm not going to do them completely for you, okay, just so you know. I'm not going to get you all the way to the answer, but I at least want you to give you a way to think about it. Okay, I want to know, does this parabola ever intersect this line? Okay, this, by the way, is going to be a horizontal line. This is going to be an upside down parabola. So I want to know, does this parabola intersect the line? Does it sit underneath it? Does it go up above it? Does it just brush against it once? Okay, I want to know how many times are those two things going to intersect. Okay, spoiler alert, it's going to be 2, 1, or 0. All right. Well, if I want to know if they intersect, doesn't that sound like systems of equations? If I treated this like a system, I could do substitution. And I could take this -2 and put it in place of y up here. So I would turn my equation into this. -2 equals -1/4 x squared plus x minus 3. And then what I'm really asking myself is, how many solutions does this have? How many answers are there that would make that true? Which again is the same question as me asking you the number of roots or the number of x-intercepts, or like if you look up at 6 through 9, the number of real solutions. Okay, even up here in 4 and 5, I was asking you for real solutions. That's what I'm asking you here as well. So let's think about what we did in all of these problems that told us how many solutions that we have. Okay. There's an easier way to do this also. If you have a graphing calculator in your hand, I bet there's a way you could figure out how many times this intersects with this. Be sure nice if you had a picture of that, huh? That would probably give you your answer, and that's a perfectly fine way of justifying your explaining your reasoning. Perfectly fine way to explain your reasoning is to say, hey, I looked at a graph, and this is what happened. But this is the mathematical way to solve it. Okay, 13. The graph of y equals 4x squared has one x-intercept. That means that this must sit right on the axis. And actually, because that's like a parent function, because that hasn't been, there's no h or k or anything, I actually know it's going to sit right at the origin. Okay, so this is the original parabola. And it has one x-intercept. I want to know, how many x-intercepts does this graph have? If I put a number, so all of this is just saying, if I put a number in there for h, if I put a -3 or a +2 or whatever, if I put something in for h, how many x-intercepts is it going to have? And what I want you to think about for that one is, what does this number do to a graph? Okay? So ask yourself, what will putting a number do to the graph? And once you know that, you can think about it in terms of this picture and think about, is it going to affect my x-intercepts? Is it going to change how many x-intercepts I have? And if so, how will it change? Okay, so think about that for 12 and 13, and really both of these questions are easier than you think they are. Okay, all right, so hopefully that was a good enough overview of the things contained in this packet. If this is the first video you're watching, I have done videos for a selection of problems from the whole rest of the packet, so go back and check those out if you're stuck on any of them. And remember that your test is next week, Tuesday.